Imagine two boxes. Each box has 100 people. Box 1, those 100 people are diseased, and box 2, those 100 people are healthy. Now imagine test 1. This test is 100% sensitive, so it picks out all 100 people who are diseased in box 1. Now imagine test 2. This test is 100% specific, so it picks out all the healthy people in box 2. What that means is it will be negative in all the healthy people in box 2. A 100% sensitive test will catch 100 out of 100 diseased people, and 80% sensitive test will catch 80 out of 100 diseased people, and a 50% sensitive test will catch 50 out of 100 diseased people in box 1, and a 100% specific test would catch 100 out of 100 healthy people, meaning the test would be negative in these 100 people in box 2. A 80% specific test will be negative in 80 of those 100 people in box 2, and a 50% specific test would be negative in 50 out of 100 people in box 2. Now imagine test 3. This test is 70% sensitive and 90% specific. It would identify 70 out of 100 diseased people in box 1, and it would identify 90 out of 100 healthy people as negatives in box 2. If you prefer a 2x2 table, you can simply convert this visual data into a 2x2 table. Here, the box 1 was simply the has disease column, so true positives and false negatives, and box 2 was simply no disease column, so false positive and true negative. Likelihood ratios simply follow from that concept. A positive likelihood ratio is the ratio of positives in box 1 divided by positives in box 2. Positives in box 1 is true positive. Because there are just 100 people in box 1, we can also say it's true positive rate or sensitivity, a test identifying diseased people. Remember, everyone in box 1 are diseased people. Positives in box 2 is a false positive because remember, everyone in box 2 are healthy people. It could also be said that positives in box 2 is false positive rate because there are just 100 people. If you think about it, that is the complement of specificity, or 1 minus specificity, a test failing to identify healthy people. Similarly, a negative likelihood ratio basically answers the question, how much does the odds of disease go down when the test is negative? And it is calculated by all the negatives in box 1 divided by all the negatives in box 2. Think of all the negatives in box 1. They are simply what the sensitivity missed. So 1 minus sensitivity, a test failing to identify sick people. All the negatives in box 2 is basically specificity, a test identifying healthy people. Note that when you have likelihood ratios calculated, you can simply multiply the prior odds to get the odds after the result of the test is available to you and is positive. You simply cannot do that with probabilities. You would have to convert probabilities to odds. One reason for that is probabilities run from 0 to 1, which is not true for odds. A discussion for another day. In summary, if you can imagine two boxes, box 1 with 100 diseased people and box 2 with 100 healthy people, then you can think of a mental model that will help you solve sensitivity, specificity, positive likelihood ratio, and negative likelihood ratio. Sensitivity there is everyone that the test flags as positive in box 1. Specificity is everyone that test flags as negative in box 2. Positive likelihood ratio is the ratio of positive in box 1 divided by box 2. And negative likelihood ratio is the ratio of negatives in box 1 divided by box 2. USMLE.ink is where I teach statistics.